So this is a simulation of the contest. Going through all these steps hopefully will prepare you for what you're going to be doing on Friday. So number one, you're going to be given a range, 3.2, and an angle, 55. Y displacement, 0. This is for your symmetric shot. These are just made up numbers. You have to find the initial velocity that's going to allow you to hit the target. And hopefully you will, but if you don't, it's not a big deal. So you need to use the range formula. You're going to be shooting like this. Here's your launcher. Here's the target. This is the range. Make that a little bit bigger. Maybe I need to zoom in. And the range is V0 squared, where this is V0, sine 2 theta, where this is theta, over G. And you're given the range. That's, in this example, 3.42. G is 9.8. Theta is 55. So this is going to be 110. And you just have to solve for V0. So you're going to get that. And then if you happen to have a nifty calibration graph, if you have a calibration graph, you can look at it and say, here's the answer. 5.78, that's the answer, number one. How far do I need to pull the bands back to shoot at 5.78 meters per second? If you don't have a graph, then you're just going to have to wing it. And you may take several shots to get into the sand, which means no bonus points for you. So number three, you keep shooting until you do make it into the sand. And this shows the impact point right there. So that's where it hit. Number three asks how many bonus points you get. And basically for the first 10 centimeters and then the next 10 centimeters and the next 10 centimeters, you can get bonus points. So we're in the 1 bonus point range. 10 to 20 centimeters is 2 bonus points. Inside the 10 centimeters, 3 bonus points. And if you hit the egg in the middle, that's 5 bonus points. So this is just 1 bonus point. That's the answer number 3. Again, here are the answers we can check as we go. 1 bonus point. The answer to the next one is going to be 5.96. So the next one asks, given it, so it says it shows the actual distance from the projectile impact point to the muzzle. So from this, the launcher is over this direction. It's 3.41 meters away. So that shot a little too far, which means your projectile went a little too fast. But that's all right. You just need to know how fast it went. And you find that out using the range formula again. So now you put in I don't know why I had 3.42 there. I'm not going to go back and fix this, but I just want to get to the bottom of this. That was supposed to be 3.2. So earlier this was 3.2. But now it turns out that your projectile actually went 3.41 meters. So you need to put this range in, same angle, and then calculate what the velocity, the initial velocity really was. And if you do that with 3.41, you're going to get a different answer than if you use 3.2. And the answer is 5.96. That calculation, that's going to be a super important bit of information. That's going to allow you to shoot the asymmetric shot. If you do everything just like you did on this last shot, you can count on that being the velocity. Hopefully you've got a precise launcher and it'll do it the same way. So number 5 is telling you what the Y displacement is going to be for the asymmetric shot, and you're supposed to calculate the X displacement. Let me go over that, zoom in. So it's going to be like this. You have just figured out what this V0 is. I'm going to write 5.96. That's just the example. And this angle is 55 degrees. Again, that's just the example here. And the Y displacement for this shot is negative 0.85 meters. So what you need to figure out is what's the range going to be? What is delta x? Because you're going to tell me where to put the target, and then you're going to shoot and you're going to hit the target, or at least hopefully you're going to hit the target. So I'm going to write down some things that we know about this. We know V0 is 5.96. And before I write, well, I'll write down the other things we know. We know theta is 55 degrees. We know delta y is negative 0.85. And we know the acceleration in the y dimension is negative 9.8. And I think that's about all we know. But we can figure out some other stuff really easily. This represents V0, and this represents V0x and Vx, and average Vx, and this represents V0y. So I'm not going to calculate it, but you can use that angle and this to get V0y. So I'm going to put V0y on the list of things we know, and V0 and Vx and V0x and average Vx on the list of things we know. I don't know what they are, but we can know them very easily. And what we're trying to get to is delta x over here. I know I haven't laid this out like we normally do, but I'm trying to do this quickly. So what I recommend is using this formula next. The v squared equals v0 squared plus 2a times displacement. I'm going to put in some y's just to indicate all this stuff is in the y dimension. So this is a kinematics formula we can use in the y dimension, and we can use it to find Vy, because we have we have V0y, which we can get from up here. And we have the acceleration in the y dimension, and we have the displacement. So we can calculate Vy. And once we have Vy and V0y, then we can get, I'm just going to add to this, delta y. And once we have delta y, once we have Vy and V0y, we can get delta Vy. So change in velocity. And we can use the acceleration formula. We have the acceleration, which is delta V over delta t. Once we get delta Vy, we can put it in this, and we can put in 9.8 negative, and we can find delta t. And finally, once we have delta t and we have average Vx, we can take those two things and use average x velocity equals x displacement over t, and you can find the x displacement. So if you do all that, if you do all that for number 5, the answer you should get is 3.92 meters. So you have me put the target 3.92 meters away, and then you shoot. And suppose this happens. The launcher is down here. The target is right there. Your first shot lands here. Your second shot lands there. I'll give you 2 spheres. You have 1 minute to shoot them both. So we need to figure out average longitudinal error, and lateral error. And longitudinal is just the word I'm using for in this dimension right here, longitudinal dimension. So longitudinal error, we've got 8 centimeters of error on this first shot. It's 8 centimeters past where we're supposed to be. And we have 7 centimeters of error on the second shot. Just use the absolute value. They're both, this one's 8 centimeters off of this center line. That's the distance it was supposed to go. That one's 7 centimeters off. 8 plus 7 is 15. Divide by 2, and you get 7.5. So that average is 7.5. Lateral error, we've got 10 centimeters of error here, 22 centimeters of error there. Add them up, that's 32. Divide by 2, that's 16. So the average lateral error is 16. And here are those answers. Number 7, what's the base score? So the base score is going to be the same as the longitudinal error. I think that's a fair way to do it. It's pretty tricky to aim these things left to right. So left to right is going to be determining some bonus points. Distance is going to determine the base score. So the base score is the same thing as this. So number 7, 7.5 is the same as 6A. Number 8 is asking how many asymmetric bonus points do we get? So you get bonus points for having close shots in the lateral dimension. Since the average in that dimension is, 16? 5 to 10 would have gotten us 2 points, but 16 is between 10 and 20, so we get one bonus point there. So number 8 is 1 bonus point. Number 9, there are all kinds of different ways to do this, and I'm not going to go through the steps, but you can choose any angle you want, and for that angle, you need to calculate an initial velocity that'll work. That'll have an x displacement of this and a y displacement of that. And if you want to check to see if your numbers work, if you come up with a couple of answers, you can go to my website, go back to class number 32, open up this spreadsheet, go down, go to asymmetric flight, and then put in, let's see, where are those numbers? So I'm going to check mine. So I said 60 degrees and 5.71 meters per second would work. So here I've put in 5.71 and 60 degrees, and I put in a y displacement of 0.9, and when I do that, I get a range of 2.2. So that matches up what it's asking for here. I want a y displacement of 0.9, and I want an x displacement of 2.2. So if you want to check yours, you've got to enter 0.9, and 0.9 goes there, and then your angle and your initial velocity. Finally, again, if you have a calibration graph, that's going to give you a head start on the free throw contest because you're going to be able to shoot at that velocity or pretty close to it. So finally, this is just having you try to calculate your overall score. And 3 buckets were made. 3 buckets is 3 bonus points. All right, let me do this. So if you look back at what we've already done so far, there was 1 symmetric bonus shot or bonus point, 1 asymmetric bonus point, and then 3 free throws. And the base score was 7.5. So overall score is 4.25. And what this does is it takes the 7.5, and then this 1 means that 10% is reduced from that. That gets us down to 6.75. This next 1 takes off 10% from that, and that gets us down to 6.08. And then this 3 takes off 30% from 6.08 to get us down to 4.25. That's the final score. And if you want to know what that would be for a grade, open up this one, put in that score, 4.25. That would be 100. If it were 14.25, it would be a 96. If it were 50, it'd be an 86. If it were 100, looking pretty bad, 34. 124, 1.9, 125, 0.3, 126, 0.